Hey, welcome everybody to Solar Noon Tuesday. I'm Jay Warmke with solarpvtraining.com. And if you're new to this, what we do during these sessions is to try and recap what's happening in the world of solar for the past week or so. And then I try and highlight any webinars or conferences that are coming up that people who are interested in solar might be interested in. And then we try and go into a topic of a deep discussion type topic of something that is related to the solar industry. This week, what we're going to be talking about is all of the rules and requirements that are around rapid shutdown. And if you've not heard about rapid shutdown, don't know what we're talking about, well, then you're in for a treat. So I'll get into that when I get into it. All right. So this is the news for the week of March 23rd. Sorry, had to mute somebody. So let's go ahead and jump into it. Several U.S. farmers and nonprofit organizations have filed a lawsuit against the Trump administration last Thursday, arguing that it was illegally withholding Department of Agriculture funds that have been awarded under the USDA REAP grant program. Now, these REAP grants are being evaluated as part of the activity happening in Washington with the new administration, and they're put on hold along with funding from the USDA for conservation and other farm programs. The five farmers have involved in the suit were awarded grants under the USDA REAP program to install solar panels on their farms. The three nonprofits say that they were awarded grants under the Forest Service program. Now, the farmers argue that they've entered into contracts with solar installers. They've expended money on these projects. Many of them, maybe they're already complete. And because all of these grants are retroactive, you've got to actually spend the money up front, and then you're reimbursed the percentage at the end. And they're afraid that they will not be able to recover the funds that have already been spent if these grants remain frozen. The nonprofit groups are claiming that they're having to furlough or cut staff as a result of these freezes. The IRA included $18 billion for these USDA programs. And a lot of these programs actually benefit Republican leaning states. A recent analysis by the University of Illinois found that $12.5 billion of this funding has not been released yet. And much of this is in six specific states. There's the states of Arkansas, California, Minnesota, Missouri, Mississippi, and Texas. Each one of these stand to lose as much as $400 million if these funds are ultimately not allocated. Agricultural Secretary Brooke Rollins has said that the agency is beginning to unfreeze these IRA funds, but he has not released any information as of the information that I've researched as to how much of the funds will be released and the timeline under which they will be released. The on again, off again budget saga continues in other areas as well. Here, the 2 weeks ago, the Environmental Protection Agency terminated grant agreements in the amount of about $20 billion that were part of the Green Bank program that was to finance climate friendly and clean energy projects. Climate United and two other nonprofit groups, the Coalition for Green Capital and Power Forward Communities, argued that the freeze not only prevented them from financing new projects, but it was forcing them to lay off staff. They said the allegations of mishandling funds, which were part of the justification for canceling these grants, were utterly without merit. They claimed that the action by the Trump administration was simply a breach of contract. A federal judge agreed with them last Tuesday and blocked the Trump administration from terminating those grants that had been awarded. And he called the government's allocations vague and unsubstantiated assertions of fraud were simply insufficient to take the actions that they did. Now, the order by U.S. District Judge Tanya Chutkan, I believe, prevents the EPA from ending the grant program. It also blocked Citibank, which is the holder of these funds, from returning those funds back to the U.S. government or awarding them to anyone but the original recipients. The nonprofits had asked the judge to unfreeze the funds. She refused. She basically said, okay, we're going to maintain the status quo as this review process continues. And there's some good news, bad news on the climate change front. First, the bad news. Well, 2024 was the warmest year on record in the 175-year observational record, according to the World Meteorological Organization. They issue a report called The State of Global Climate 2024, and it pointed out that there were massive economics and social upheavals from extreme weather and the long-term impacts of ocean heat as well as sea level rise. The report stated that the world experienced 152 unprecedented events, weather events, and they also had 297 unusually extreme weather events. The WMO defines an unprecedented weather event as those that are rare or unusual in terms of magnitude, location, timing, or extent, and which are worse than any ever recorded in that specific region. Topping the list included heat waves. There was extreme wet and rain events, flooding, cyclones, drought. In total, these events were linked to about 1.1 million people being injured, 1,700 deaths, and about 825,000 people being displaced. And the good news, according to a new analysis by Carbon Brief, the UK's 2024 emissions fell 3.6% last year to the lowest level seen since 1872. The country's coal use was also the lowest it's been since the mid 1600s. The largest factor in these emissions falling last year was a massive 54% drop in the amount of coal that's being used in the UK over recent decades. In fact, the amount of coal that was used in 2024 is the lowest it's been since 1666, and that was the year of the Great London Fire. Some of the major contributors to this reduction in coal use is basically they shut down the last coal-powered electrical plant in the country. They also shut down the last steelworks that used coal blast furnaces. There's also about a 40% increase in electric vehicle usage within the UK. And basically, the report states that the electrical grid in the UK is the cleanest it's ever been. And that is the news I had. Although one item came up recently that I just thought I would add to this, and that was an announcement by BYD that BYD is an electric vehicle manufacturing company out of China. It's actually the largest selling electric vehicle auto company in the world. But they've just announced that they've got a fast charging system that will charge an electric vehicle up to 250 miles of range in 5 minutes. So that's a massive change that's out there on the horizon. I guess making an announcement doesn't necessarily mean it's true, but we will find out. And if that's true, that's a big breakthrough in EV technology, charging technology, I should say. Does anybody have anything they want to add to our news of the week here? Well, we've got everybody set. Give you just a second. Nope. Okay, everybody's being shy. All right, so let's go ahead and jump into some of the announcements here for the week. This December 24th through the 27th, we've got Distributech in Dallas, Texas. And that's going on as we speak. Also going on this week is the NABCEP conference in Reno, Nevada. And NABCEP, of course, is primarily focused on installers and designers of PV systems. March 27th, that's going to be 2 days from now. Solar United is having a coffee chat. A lot of what they're trying to talk about is how to influence legislation. So if you want to be part of that, it's at 11:30 a.m. Eastern Time. All of these times are going to be Eastern Time that I'm giving you. April 1st, using available software. And that's for, I assume, PV, using the software that's available there. And oops, I'm having a little trouble there. There we are. And April 3rd, homeowner trends, 2 p.m. Eastern time. This is something about, I guess, demographic changes that are taking place when you're out there selling systems. Then there's conference May 19th through the 22nd, Clean Power Conference in Phoenix. And then, of course, our shameless plug for our programs. We've got online training as well as virtual or self-paced or in-person training. And that is on solarpvtraining.com. Those are the events. Does anyone have anything they want to add to that while we're at it? Okay, give you guys that second. And as per usual, I think one of the advantages of this format, because we have quite a number of people online, it gives you the opportunity to chime in, give me your opinion, or ask a question as we move forward. Okay, so let's go ahead and get into the topic that I have for today. That's talking about rapid shutdown. And before we get into the topic, though, I realize I've been remiss each time in just reminding people that this particular program, Solar Noon Tuesday, I'm working with ETA International. That's the Electronic Technicians Association International. They do have a certification program for photovoltaics that I've been quite involved in. I actually sit on the board of directors of ETA. And of course, really, there are two certification programs that are focused on solar within the United States and North America. ETA is one of them. NABCEP is another one. I always like to tell people ETA is very well known within the community college and technical school world, where NABCEP is pretty much unknown within that world. And NABCEP is very well known within the solar installer world, whereas ETA is relatively unknown within that world. But both of these certification programs are typically accepted by any of the authorities having jurisdiction that require certification within as part of grants or as part of just doing installation. So, but ETA provides half an hour of continuing educational credit for these sessions. So, and they're all on our website, all of the back sessions. So just want to give them a little bit of plug since we're affiliated with them. So anyway, now get into the issue of rapid shutdown. So let's talk about what rapid shutdown is and why it's an issue. And the term is not exactly 100% evident as to what it means, but this is my attempt at a drawing of a typical old school solar installation. And I'll explain what you're seeing here. The solar panel up on the roof, residential system, obviously. And oftentimes you've got a combiner box or a junction box that's hidden underneath the solar array. Drill into the attic, and then you run that conduit with your DC wiring down through along a truss, maybe in the attic. It goes down through the wall. All of these dotted lines are just indicated that those wires are traveling somewhere inside the building and may or may not be visible. They go down to a DC disconnect, which is oftentimes located somewhere near that meter. And then from that DC disconnect, very often the inverter was installed down in the basement. So that's what I'm trying to show there, that you go down from the DC disconnect to this inverter. There's going to be another DC disconnect down there. The DC disconnect has to be located within 10 feet or 3 meters of the inverter. And then from that inverter, you go back up to an AC disconnect. That AC disconnect is supposed to be located within 3 meters or 10 feet of your utility meter. And then from there, typically goes back down into the basement to hook into your service panel, into your circuit breaker box. So that's what you're seeing with this old school installation. And 10 years ago, this was kind of the way everybody did it. And so what's the problem? Well, let's say that you've got a house, your house catches on fire. So here's my cutesy little representation of the house catching on fire. Okay, so, and it's sunny. The sun is shining. The first responders come out to the house, and the first thing they're going to do is try and disconnect the electricity. So they're typically taught to go ahead to the electric meter and you just pull the meter. The meter acts a bit like a fuse. You know, it makes the connection between the home and the electric grid. So when you pull that meter, it's like pulling a fuse. Now the NEC in 2023 requires that there be an AC disconnect or a utility disconnect at the meter. So if you're doing installs now and you have to abide by the 2023 code, you're going to want to have a disconnect there at the meter built into the box. That's just to facilitate these guys being able to shut down the house from the grid without actually having to pull the meter. Now they can just flip a main. So that's where we're moving there, but it's the same effect. You're going to disconnect. Now on your meter, there's going to be a little sticker that says, hey, warning, this system has an alternative power source. In this case, it's the solar array. So they look around and they look for the main disconnect. Well, the main disconnect is your AC disconnect for your solar array. So they go over, and that's why it has to be located within 10 feet. So it should be visually apparent, readily accessible, and externally operable. So you should be able to pull the lever externally without having to open it up. And it should be well marked. So they go over to that AC disconnect, they turn that off. So I've just shown that they've disconnected the meter there and they've disconnected the AC disconnect. Now the array has been shut off in theory. But what actually happens is the inverter sees that the signal from the grid is no longer present. And the anti-islanding functionality of that inverter that's built into all inverters that are UL 1741 compliant, it recognizes there's no grid signal and it turns off. But the wire that goes from the array to the inverter can still be live. That live wire is running, and I just highlighted it in red. They're down all the way down to the inverter. So the danger there is that the firefighter thinks there's no power in the home, but there are actually lines that are still live, hidden from them, as much as 600 volts, because that's the limitation of solar power in a residential setting. So they could climb up onto the roof and cut through the roof, trying to vent some of the smoke, some of the gases that may be building up inside the house. They take their chainsaw, they cut right through it. They cut through a 600 volt line, and they are injured or die. So the NEC said, when you go to turn off that main disconnect there, we want the power to turn off at the array so that there are no live wires going through. All right. Another issue with solar is that oftentimes first responders are going to use what they call a hot stick. And it's a device that will actually, they can wave it around and without actually touching um, the electric source, they can determine if there is electricity present. They'll use these in automobile accidents when there are down power lines, things like that, just so that you know that it's a safety tool. But it only recognizes AC current. So if in this previous example here, those wires going from the array down to the inverter, that's DC. So that hot stick is not going to recognize it. So that presents another further danger to the first responders because their normal tool for detecting if electricity is present is not going to be effective in this particular situation. So that's another issue. Now, I tried to do some research to find out just how many firefighters were injured in this way. They just don't keep those statistics. They are I would just say when this rapid shutdown thing came into effect, it was more of trying to address a potential hazard rather than reacting to events that had already occurred. I'm sure somewhere, sometime, a firefighter was actually, subject to electricity coming from the array in this manner, but it's not the primary reason for this. I think somebody in the process just identified that it was a potential risk, especially as more and more systems are being installed on rooftops. And so let's address it early. The NEC is primarily a safety document. They don't really care how much your system costs, and they don't care if it works particularly. What they're trying to make sure is that it is safe when operating the way it's designed. This statistic here from the NFPA was interesting because actually firefighter injuries have gone down pretty dramatically. So that's good to see, I guess, and it's because they're more and more often putting in systems like this that are anticipating and trying to prevent. So that's the rationale behind this. It is a safety issue, and it's primarily a safety issue for first responders. Okay, any questions at this point? Just throw that open as we move forward here. Want to make sure. Okay, so what are some of the other risks posed to first responders from solar? Well, as we mentioned, the electrical, it's up to 600 volts. That can certainly kill you, especially if the amps are enough. Battery backup. Battery backup. We'll touch on that a little bit, but the risk there is okay. So why do we have battery backup? Well, we have battery backup to provide electricity when the grid goes down. Well, if the first responders just disconnected you from the grid, guess what? Batteries are going to kick in. You're still going to have power. So we've got to address that as well. Another thing is building integrated photovoltaics or BIPV, such as solar shingles. Well, oftentimes these things are designed by their very nature to be somewhat invisible. One of the advantages of solar shingles is it's not obvious that you have solar on your rooftop. Well, if it's not obvious to people walking by, it may not be obvious to the people who are responding. And yet these things are generating electricity. So that's an issue. That's a danger and added complexity for people who are responding to these events at your home. There are also now multiple disconnects that they have to deal with. Not only can you just come and pull the meter and think that you're done, now you've got disconnects for your PV, disconnects for your battery, perhaps disconnects for a generator. So multiple disconnects that have to be dealt with. The solar array adds added weight to the roof. Not a huge amount of weight, but added weight. So that adds to the possibility in the event of a fire of that roof collapsing. Plus, solar panels will catch fire. It's hard to imagine, but they do. And so that's something. And is there toxicity involved with that? That will depend on the unit, but that's an added danger to them. And lack of roof space. So if you've just got a shingle roof or something, these first responders can just climb all over it, cut where they want to. If you've got a significant portion of that roof covered by solar, then that limits the access of the folks up on the roof. So the International Fire Code tries to set what are the minimum pathways and spaces that must be left on these roofs to provide access to first responders. Typically, for a residential home, it's going to be 3 foot on either side. They don't really specify on the eave. I guess they figure somebody's going to be on a ladder. We always recommend at least 16 inches, and that's more for wind rather than the wind catching it and lifting at the bottom of the array or at the eave. And then at the top, there's going to be at least, well, could be 3 feet, could be 18 inches if there's 18 inches on each side. And that's just that's a real cursory overview of that, because there are other issues, different things, if there's how much of the space is being occupied by the array, things of that nature. You get into commercial, it's going to be different. There are wider aisles around the perimeter. No array can be more than a certain size without pathways in between. Access, open space around access points, space around vents, things of that nature. So that's all addressed in the code. That's not the purpose of this talk, but just to let you know. So all of this began or came to a head or really entered into the awareness of the solar installer in 2014 when the code came out, and they began to mandate rapid shutdown in the National Electrical Code. So let me just sort of walk you through this process here a little bit. In 2014, Article 690.12, rapid shutdown, basically said that they started defining what they call controlled conductors. And these controlled conductors say that systems more than 5 feet, when the conductor goes more than 5 feet inside the building or 10 feet from the array, it's considered now a controlled conductor. And within 10 seconds of shutting down the system, basically turning off the AC disconnect, that has to drop down to 30 volts. So they're essentially saying, okay, outside of this 10-foot perimeter of the array, and only 5 feet if it's going straight into the building, after I turn this thing off within 10 seconds, we need that thing to be down to 30 volts, not 600 volts. The voltage and power is measured between two conductors. All right, that's fine. Between the positive and negative, or the positive and the ground. And rapid shutdowns, they have to be labeled and such, and they have to be listed. But essentially what they're saying is we want that within 10 feet to drop to a relatively safer level of voltage. So how do we, and also the system has to be labeled. And this was the label they chose. This thing needs to be on the AC disconnect. I thought at the time when all of this was coming out, they came up with this thing saying, if the system is protected by rapid shutdown, it has to be labeled. I always thought that was a little bit backwards. Seems to me that it should be labeled if it's not protected, but I guess the thought process there was you can't go back and force people with grandfathered systems to go stick labels on something. So they just want it to be labeled that it is in fact protected. All right, so what are some of the options? How could you comply with this ruling in 2014? One way is to stick the inverter up there next to the array. As long as you stick it within 10 feet, you're going to comply. So that works okay in this example for on a commercial building. You could just take that inverter system, and rather than stick it down inside the building somewhere, you just move the whole assembly right up next to the array. So now when you disconnect, it shuts down at the inverter. The only live piece is going to be that short little bit of conduit between the array and the inverter. So problem solved. You're within 10 feet. you got that there. But for a regular old home, sticking this big 100, pound unit up there on your shingle roof, not a very practical solution. So a different solution would be microinverters. It is effectively the same thing. You're taking the inverter and you're moving it right up next to your source of power. With a microinverter, of course, you connect one inverter to each panel. This one here is an example of an N phase. And of course, each panel just connects directly into that inverter. The inverter itself has the anti-islanding provision. So, as soon as it loses sight of the grid, it's going to shut down. Problem solved. You've got the array shut down right at the source. So there are no live wires traveling through the building. You've shut it down right there. The downside of that is, of course, in 2014, these things were pretty pricey. So you've got one little microinverter attached to each of those panels. So another option emerged, of course, right around the same time these things began to be popular, is power optimizers. And power optimizers was something I believe it was the technology maybe was initially patented, I'm not really sure, by SolarEdge, but they certainly became the dominant player in this marketplace. And essentially what they said is, okay, you don't need to put the whole inverter up there in the form of a microinverter. What we really want you to do is to have an electronic device connected to that panel that shuts it down when you lose sight of the grid. And if we're going to do that, why don't we also put the MPPT, the maximum power point tracking that's normally located within the inverter, let's put that up in the optimizer so that each panel now functions separate from every other panel. This is really good if you've got a shading environment. You don't have loss due to the worst panel in a string drawing down everybody else. So there's certain advantages, obviously, to having every panel operate independently of every other panel. You get the same effect with the microinverter, but this, you're not putting the inversion thing within that unit, so you can save some money there. And then, of course, if you're going to do that, why not put communication systems in that piece of electronic as well, so that I can monitor the performance of each of those panels independently. Once again, that's a functionality that's within the microinverter, but now we're replicating it there. In fact, we're doing pretty much everything a microinverter does, except converting the DC electricity of the panel into AC electricity. So that's what an optimizer is. Basically, a microinverter without the inverter. And each of these are attached to the panels. So that was an item. So that's kind of option number 3. Option number 1, put the big inverter up there next to the panel. That works fine for commercial systems. Then microinverters, optimizers. And the third choice at the time was a remote disconnecting switch. And here's an example. This one's from Midnight Solar, and they just called it the birdhouse. But I always think of it as like that emergency disconnect that you see at gas stations. If all hell's breaking loose, hit this button and you're just going to shut off everything. So that's kind of how I view it. But what you're doing there, this is going to be located down at the near the meter. And you just pull that thing to open, punch the button. It's going to disconnect at the combiner box or the junction box that's right up there at the solar panel. So you're disconnecting within that range, within that 10-foot range, up there at the panel. Now, this is demonstrating you can actually disconnect multiple disconnects with the same thing. So you're shutting it down in a bunch of different locations. But there was like an RJ45 jack. It's got a communications jack that has to be connected up. So there's additional wiring, there's additional components. It added quite a lot of cost to these systems. So all of these were really adding cost. But like I said, the NEC doesn't care. They just want this system to be safe. So those were pretty much the four options that you had in 2014. All right. I'll give you an opportunity to give a question about the going back 10 years ago. This is the olden days of solar. Anybody have a question about 2014? Okay, so
Jay,
yeah, go ahead.
David, I was thinking you work with a couple of rapid shutdown solutions in the commercial sector in Trinidad. Um, as I could vouch, it does add significantly to the cost,
Yeah,
especially with commercial. I work with optimizers, not with SolarEdge, but Huawei also use optimizers for their solutions. Then you have AP Smart and Tigo, which kind of do the similar thing. They have to have a initiator switch installed separately. So yes, it does lead to complexity. It also leads to increased cost. And there is many advantages. I vouch for it. It does offers maintenance options on a better scale, especially if you have a large PV array and you have an optimizer. You can actually see if an individual PV module is misbehaving, as the case might be. So
yeah.
there's both pros and cons to these things. Yes, that's just my contribution.
Okay. Do you have the requirement in Trinidad to do rapid shutdown, or is that just something you add into your systems?
It was not stated in our standards yet, but the fire services and our government electrical inspectorate is aware of it, so they are kind of moving towards any commercial large-scale PV roof is something that they want to have installed.
Okay. All right, so let me move on then. Thanks, Devanan. To the 2017 code, because there were significant changes made in 2017. And you can just see by the bunch of text there over to my, I guess that's my left, is these things get more complicated. The code always seems to get bigger and more complicated, it never gets simpler. So what they're saying, and I didn't want to, well, if we walk through that real quickly, you've got, it did point out the exception for ground mounted systems. So these are really intended for rooftop systems only, occupied structures. So it became a little bit confusing. Do we have to do this on everything? I mean, the rationale there is if you've got a system out there on the ground somewhere and something's catching fire, the first responders can just walk and go, hey, let it burn. I mean, just I'm not going to put myself at risk. We'll just let this thing burn down. So if it's just a ground mounted system out there by itself. So then there were also changes in the boundary. So rather than walk through that, let me just, and then they changed the label, of course. So this is the 2017 switch label that has to be there. But essentially, so what were the main changes here with the 2017 code? Well, it basically said that anything more than 1 foot outside the array has to shut down to 30 volts within 30 seconds. So that was a significant change. Before it was 10 feet. Now they're saying 1 foot. And then everything, all the conductors within the array boundary itself have to shut down to 80 volts or are limited to 80 volts within 30 seconds. So what does that effectively do for us as installers? It kind of took away two options. It took away, I mean, realistically, you probably can't put the big inverter up there on the roof. It's saying it's got to be within 1 foot. I guess technically there may be systems out there, I'm not familiar with them, that are literally just connecting up within 1 foot. Yeah, I guess. But it certainly took away the remote disconnecting switch. So we really got into on all buildings, there's got to be some sort of module level power electronic device. We just call these MLPEs. that is attached to the panel itself. That's effectively where we got to in 2017. So those module level power electronic devices come in a number of different flavors. Sort of as Devin indicated, there is the microinverter, and the microinverter is still a good option. In fact, that's one of the reasons why 50-60% of all systems installed on residential buildings here in the United States are microinverter systems, is because it complies with this rapid shutdown requirement. And also, these things have gotten more efficient. They've gotten less costly per unit, or just doing a better job for less. But they do the DC to AC conversion, so it's a true inverter. They do optimization, right? They have the MPPT, the maximum power point tracking, within each device so that every panel is operating independently of every other panel. They also have monitoring. They've got communication there. So again, as Devin pointed out, it's nice to be able to look at your phone or look at your monitoring system and see, is one panel malfunctioning? Is one producing worse than others? Has one just shut down altogether? What's the impact of shading? Things like that. So you can monitor them on an individual basis. And of course, the rapid shutdown is there. That's basically the anti-islanding. As soon as it loses sight of the grid, boom, shuts off, clamps down. It also is an added benefit for installers. You can hook this module level power electronic to the panel when you're installing it. And until you've made that final connection to the grid, it's going to clamp down on any potential power that's flowing through those lines. So that's nice, so you don't have to worry about, like in the past when you would hook up a string of solar panels together. If the sun is shining on them, you're dealing with live power lines. And if you happen to be grounded in some way, you could receive a significant shock. So, of course, they used to recommend covering the panels with blankets and things like that as you're installing it. But with these module level power electronics, you just click that panel directly into that microinverter, and until it sees the grid, it's not going to be generating any power. So, second option, power optimizers. What that does is, as I said, pretty much everything except convert the power from DC to AC. So, I've worked with these Solar Edge ones. I haven't worked with some of the others like Huawei, I think Devin had said. I know Tigo has some of them as well. The optimizers kind of do the same thing. They clamp down on the power so you can hook them up. Now, these optimizers, at least the ones from Solar Edge, don't stop all power from flowing through. They actually produce a 1 volt signal volt. It's minimal amps. So even when it doesn't see the grid, it's still going to be generating 1 volt. And the advantage of that is you can hook up all of your panels to all of your optimizers. You get down into wherever you're making the connection to the fixed voltage inverter that this system connects to. And you can just take a multimeter and test the line. And if you've got 22 panels hooked up to 22 optimizers, you should get a signal voltage of 22 volts. And that's going to tell you, hey, all the wiring up there on the roof is fine. At least it's, to this point, seems to be connected properly. If you hook it up and you only get, 15 volts, there might be a problem. Something came disconnected. If you get no volts, you probably don't have everything hooked up the way it should be. So that's helpful. And then Tigo, these are the units I have here, but they also have module level power electronics that do the monitoring and the rapid shutdown. So you can monitor every individual panel. They're not doing the MPPT. They have that. Tigo has that as an option, just like Solar Edge. Or you can do just the rapid shutdown. So each one of these, the reasons they're going to be a little bit cheaper. The Tigo units there are pretty much designed to go with existing string inverters. Systems like SolarEdge, they're a complete package, so their string inverter works with their optimizers. But Tigo and there's probably others as well, but they're the main one. Work with companies like Fronius or SMA to make these rapid shutdown units that will work with those models. So, so that's did somebody have a comment? I just heard something there. Okay, so anyway, what does this mean for panels? I was trying to do a little bit of research because I remembered years ago when in 2017 when this came out, it was an issue, but I couldn't find much documentation on it. But the issue I'm trying to address here is the 80 volts within the array itself, within the boundary of the array. And at the time, what some people were doing to save a little bit of money is you could get these optimizers that will, say, take up to 1200 watts. So you could hook up multiple panels in a string and then hook up that string. There could be 2 or 3 panels that are hooked up to a single optimizer. So, for example, if I had 325 watt panels and I've got an optimizer that can handle up to 1200 watts, I could hook up 3 of those in a string and then just hook up that little string to the optimizer. Now, the downside of that is if one of those panels is shaded, it affects all 3 of them. So the MPPT, is not as effective as if you're hooking them up individually. But then if the voltage of each of those panels exceeded, in this example, let's say 30 volts, and I hook up 3 of them in a string, now I'm up to 90 volts, and that exceeds that 80 volt maximum. So I think what ended up happening, we saw a lot more of these multiple port, like you see there on the right, optimizers that are designed to take 2 or even 4 panels, but you hook them in individually. So the male and female plug hook in. So this example, I've got 2, it will receive 2 panels. That allows for multiple MPPTs within that optimizer, which is great. And it also helps manage to make sure everything is below 80 volts within that array. So I was trying to find if there's supporting material out there or whatever. Maybe it's just become a non-issue because the manufacturers have adjusted to this so that none of these things exceed. When you look at the panel specs for these optimizers, all of them have a hard stop at 80 volts. So they say we will not generate, like that one on the left happened to be, I think, a 1200 watt optimizer, but the maximum it's going to send out is 80 volts. I'm sure that's because of the rapid shutdown, because it's going to be within the array boundary. So, all right. And then the other, or I think the, there were some additional changes in the 2023 code. Not many. It was mostly just defining some of the other exceptions. For example, it was basically saying that like carports, solar trellises, these are unoccupied structures that are physically separated from the home, are not required to comply with the rapid shutdown. So they were just sort of defining that or redefining it. There's always questions that arise. I remember if it's physically attached to the home, typically they're going to require it as rapid shutdown. But if it's a carport that's physically separated, or there's some question about separated garages, barns, things like that, that's going to be a code official, because it's still not 100% sure. Because who knows, somebody could be sleeping in the garage or sleeping in the barn or whatever. So you'll just have to get guidance from your local official. Then there's also saying that if it's a ground mounted system, but you're making a connection to the side of the building. So that was another thing that needed clarification. And they basically said, yeah, that doesn't count either. You can, if you're making, and a good example of that, would be if you're hooking it into the utility disconnect that's at your meter. That's your point of connection. It's on the side of your building. Somebody might maintain that that is part of the building and therefore it's subject to rapid shutdown. They're saying no, no. If it's a ground mounted system and you're simply making your connection at the building, not an issue. It has to be physically mounted on the building. Okay,
I,
Taylor, you had a
Jay,
comment?
yeah, I'd like to say I've seen a lot of people doing the Soul Arc installations, and which that's just one of the brands of the hybrid inverters that are a DC string inverter. I see a lot of people locating those indoors, obviously because the batteries are better off indoors as well. But I don't think they're complying with rapid shutdown, and that's something I've always sort of been curious of. Is once the code officials catch on to what's happening, as the NEC states, in or on buildings. But I do like where you had pointed out that they do allow them to be on the side of a building, but not exactly on top of a building. So I'm curious inside what that means. Obviously, it needs to be an EMT,
Yeah.
but yeah, I've seen a lot of people that they seem to be violating that rule.
Yeah. Yeah, I'm sure you see a lot of violations when you're out there in the field, especially I see a lot of violations with the setbacks, the 3 feet clear
Yes.
distance on the
Yeah.
sides and the top and on commercial buildings. And a lot of that is because that setback requirement is not in the National Electrical Code. It's in the International Fire Code. And the inspectors are not that familiar with that document. But you see that violated all the time. Looking at this exception, I would see that if you've got your inverter inside the building, even if it's a ground mounted system, it specifically says attached to the exterior of the building. So I would read that if I were a code inspector to say, hey, you got to comply with rapid shutdown
Yeah.
because you've got that in there. Yeah, and somebody in the comments just mentioned about their rapid shutdown disconnect switch that is part of Solarc. I'll get to that in a second, but that may not be enough to basically avoid this issue.
Well, yeah. So um, even if you smash that emergency disconnect switch on the outside of the building for your Solarc, the conductors that are coming inside of the structure, inside the home, are still live with that active, 300 to 500 or 550 volts roughly, I think is what Solarc allows. So yeah, I mean those DC conductors are still active. So yeah, that doesn't, in my mind, that doesn't seem to comply.
Yeah, I think the rapid shutdown initiator or the rapid shutdown disconnect in these systems is primarily to shut off your battery system.
The AC conductors, that would be because
Yeah.
a fireman doesn't want to go through the house and get shocked by some open Romex, that's all melted,
Right.
from receptacles and lights and things that could be falling in on them. So yeah.
Mm-hmm. Yep. So the other thing to bear in mind, because I'll get to that rapid shutdown here in just a second, to the rapid shutdown disconnect, is where does this apply? Because now enough time has gone by since 2014 that most states do now require at least the 2014 code, but not all of them. And this map here shows what states, at least as of April of last year, which ones are complying with which codes, because various states adopt different codes. So, for instance, I live here in the state of Ohio. Ohio actually leapfrogged the 2020 code. We never actually adopted the 2020 code. We went straight from the 2017 to the 2023, which not sure why, but they did. So the ones in purple are the 2020 codes. The ones in orange are the 2023. The ones in red are 2017. So all of those, the purple, the orange, and the reds, are pretty much up to snuff as far as requiring rapid shutdown. 2014, well, you could still use a remote disconnect. I don't see many of those blue. Looking at that map, it looks like only DC has that particular color. Then the 2011, didn't see any of those. 28 or 2008, Kansas and Indiana and New York City. What do you know? You guys are behind the times. And some of those states don't have statewide adoption. So, for instance, Mississippi, Missouri, Illinois, Arizona, Nevada, they don't have statewide adoption, but that doesn't mean, because basically you're dealing with it at the local level. So you'll have to check with your local jurisdiction to see which code applies. But I guess this map just kind of indicates that pretty much my assumption is almost everybody requires rapid shutdown. It may not be the 2017, maybe under 2024, but you're not going to get in trouble if you adhere to the 2017 code. And then this is what we are just talking about, the rapid shutdown switch, the initiator, the RSI. These are required when you have battery backup, and they typically hook in either into the inverter system or wherever that battery is managed. In this is an example of an N-phase system. So that hooks into the smart switch, and that goes outside. It's supposed to be, again, within visual sight of the meter. All of these switches are supposed to be co-located. So in this example, you can see the meter is there. The AC disconnect is there. That's the one that the firefighters would turn off under this scenario. And then you need to turn off that battery switch, essentially. And if you think about it, if a firefighter was coming and he pulls the meter, well, then the house is in theory shut down. I've always felt like the AC disconnect at this point is a redundant thing, because they say that's now going to shut off your array. Well, as soon as you pull the meter, the anti-islanding on that inverter should have shut it off. I mean, it loses sight of the grid. I guess the rationale there, at least that's what I tell myself, is not everything always works the way it's supposed to. So let's have another physical disconnection just in case. But it feels redundant. But then if you turn off your array, which is basically what you're doing when you turn off that AC disconnect, you've turned off the grid. Well, if your system's designed properly, the batteries kick in. Yeah, you're not getting power from the array, you're not getting power from the grid, but you're getting power from the battery. So then you need a switch located out there that you can turn off, and now you've shut off your battery system. So the battery system there is turned off. So now in theory, there's no power in the building. And if you have the module level power electronics, the power from the array has been clamped down or shut off at the array, at each individual panel. So it's accomplished what it's looking for. Yeah, a firefighter could still get shocked by damaging the solar panel, but it's a pretty obvious thing that they should not walk on those solar panels. They should not cut through those solar panels. Those things, fairly obvious. I guess they figure that's why, but they want it minimized. They want to minimize it to 80 volts. So that's basically rapid shutdown explained. Did anybody have any comments or any questions before we call it a day here?
Dave and I again, Jay. One of the issues that came across with rapid shutdown, especially with battery-based systems, the batteries are sometimes charged through the PV array system itself. And if you're not careful where you place that initiator switch, let's say you have it in a school and you have it outside and some school child come and press the switch, eventually a battery runs down and gets dead. And you have to go and black start that whole thing over again to get the backup and running. So you want to place the initiator switch in locations where it is accessible, but you have to be mindful of who is accessing it at the same time,
Yeah.
what they can do.
Yeah, so what you're saying is if these things are in a place where you're usually going to be a teenage boy or, a 12-year-old boy who's thinking, "Oh, it's funny, look, I'm going to turn things off." Yeah, we have that issue with not only the battery switch, but also the AC disconnect switch as well. Normally you can deal with that through your code official to ask that that switch be relocated to a different location, but you're supposed to put a sign there that tells the first responders where that's going to be. So, for instance, we did a system at a school where the meter was located right next to the front door. And everybody walking by would have been seeing this switch that says this is the turn off for the PV array. And we thought, sure enough, somebody's going to just turn that thing off. So you get a little sign saying, no, it's around the corner and down a little bit. So it's always an issue. So, Al, you had a comment there?
Yeah, my system was installed in 2019, and I have an AC disconnect basically below the utility meter.
Uh-huh.
Pretty visible, has the sign you mentioned, all that stuff. But to the best of my knowledge, I have no, and I have a Solar Edge string inverter in the basement, next to the battery, next to a critical loads panel, all that sort of stuff. But to my knowledge, there's no disconnect for that power coming from the roof into the inverter and now obvious and into the battery. Obviously on a sunny day when the grid's down, my battery will recharge, which is a great thing.
Yeah. So you're saying you don't have a DC disconnect that's out there. You just go straight from the array down to your inverter.
Right. And then
Which
from the inverter into the battery and back and that sort of thing.
Right.
But there's no outside DC disconnect. It's just the
Right.
AC disconnect.
Right.
Does
Yeah.
that shut down the power from the battery through the inverter?
Oh, no. The DC disconnect that I showed in that first example, that's not necessarily required by code. It's just that it was a normal process. The code requires that your DC disconnect be located within 10 feet of the inverter.
Okay.
So those, like with Solar Edge, are built into the inverter. That's where you're making your landing. So the DC disconnect is oftentimes fully integrated within the inverter. So you may not see in today's world a
Right.
DC disconnect outside. You're compliant with rapid shutdown because you're using optimizers. And as soon as it loses sight of the grid, you should have an AC disconnect that's outside
Right.
next to your meter. And then
Right.
from there, it goes to your service panel, right? So you go back into your service panel, or you could make a load side connection at the meter, or sorry, a supply side connection, if you needed to.
Yeah, but what I'm wondering, when the power goes down, the grid power goes down, obviously, the battery kicks in,
Yeah,
sends power to the inverter, which I think sends power to a critical loads panel.
yeah,
And powers just those loads.
yeah.
Because my battery's not that big. But so in the case of a fire or something, those critical loads are still going to be live.
Yeah, that's why you should have a rapid shutdown initiator, the RSI switch, the battery switch, out there next to your other disconnects, out next to the meter. So
Okay.
you may not have installed it when you installed your system in 2019. You probably should have. I'm sure there's an add-on type thing for Solar Edge. I shouldn't say I'm sure. I imagine there is. I know it comes with the Enphase system, but it really is just, it connects into your inverter and it goes out there and it's just a disconnect. Because for that very reason, you're going to have power to your critical loads when everything else is off.
So would this shut down the power between the inverter and the critical loads panel?
No, it would shut down between the battery and the inverter, I think.
Okay.
It
Okay.
clamps off the battery. It just shuts off the battery.
Because my installer is going to be coming back up to do some other work, so I think I'll check
Yeah.
with him about that.
The connection port will probably be within your inverter.
Yeah.
I know with Enphase, there's a place you connect to in the smart switch. So it would have to be something that's designed for that. And
Right.
it may be that your system just didn't have one. But I would check. I would check. And I'm sure there's aftermarket kind of things you could put in there, but it's a nice safety feature. Obviously, you got by without it, and the
Right.
odds that you'll ever need it are low. But that's
So I'm guessing it wasn't required in 2019. Is it required now?
yeah, typically it is. I don't have the specific notation on it, but yeah, because people are installing, I'd have to look that up. I'm saying yeah, and I'm not. I shouldn't say yeah. I would say I think so. I
Okay.
think so.
That's good. Thanks. Appreciate it.
Sure thing. All right. Let's see. We'll just call it a day. I appreciate everybody's input, and we'll see you again next week. All right. Take care.